So here we're going to look and see how can we tell if two vectors are perpendicular. So there's going to be kind of a punchline at the end here. But let's take two vectors and we'll have them come out of the origin. So we'll do, let's see, I'll start with the black. We'll have y-axis and an x-axis. And I'll have one vector kind of sticking out here. And we'll call this vector vector A, and the coordinates of this are going to be A1, comma A2. And then we'll have a perpendicular vector. So I'm telling you these are perpendicular. And this is going to be vector B. And the coordinates of this are going to be B1, B2. And let's see here, let's pull up a different color. So then what we're going to do is we're going to have this third vector that's basically the hypotenuse of this triangle. And we're going to call the endpoint of this vector B and A, we're going to call the endpoint of vector B capital B, and the endpoint of vector A capital A. So this vector is going to be BA, like so. So what we're going to do, I'm telling you they are perpendicular, but we're going to use the fact that they're perpendicular to find a general rule on proving if vectors are perpendicular in general. So let's kind of investigate what we've got going on here. What I'm going to do is I'm going to use the Pythagorean theorem to kind of look at what's going on here. So first I need the magnitude of A. And the magnitude of A, if it starts at the origin, the magnitude of A is just going to be A1 squared plus A2 squared, and we're going to square root that. We're basically just doing the Pythagorean theorem to find the distance of this red vector. So then we need the magnitude of B. Remember, magnitude is just synonymous for length, so we're finding the length of these vectors of the triangle. So the magnitude of B is going to be square root of B1 squared plus B2 squared. And then the magnitude of BA, vector BA, will be the square root of A1 minus B1 squared. So that's going to be the x distance of that green vector, plus B1 minus, or excuse me, it's going to be A2 minus B2 squared. So what I'm going to do, I'm going to shrink this just a little bit so I can fit stuff on here, is I'm going to use the Pythagorean theorem, and I'm going to plug this stuff in. So it's going to be A squared plus B squared equals C squared. And so in this case, A is going to be vector A. So we're going to do the square root of A1 squared plus A2 squared. And we're going to square that number. Plus B squared, so it's going to be the square root of B1 squared plus B2 squared, and we're going to square that number, and that's going to equal the magnitude of BA squared. So that's going to be A1 minus B1 squared plus A2 minus B2 squared. We're going to square that number. Sorry, it's kind of running off the screen here. See if I can pull that over. There we go. It's a little bit better. Squared, squared. So, let's kind of evaluate this a little bit. If we square the square root on this thing, we end up with A1 squared plus A2 squared. Square roots get canceled out by the squaring. Plus, we square the square root on the blue stuff, so we get b1 squared plus b2 squared equals, and then on the green stuff, we get a1 minus b1 squared plus a2 minus b2 squared. Okay, so let's look at the green side a little bit here. I'm just going to kind of leave this red and blue side alone. So I'm going to FOIL this. If you're unfamiliar with foiling, it's just multiplying a1 minus b1 times itself. That's what the squaring means. So when we do that, a1 minus b1 times a1 minus b1, and then plus a2 minus b2 times a2 minus b2. We get, I'm going to kind of separate this so I can tell that I'm working over here. We get a1 squared minus 2a1 b1 plus b1 squared. That's what we get when we FOIL this thing. And then we're going to do the same thing with the other part, so we get a2 squared minus 2a2 b2 plus b2 squared. So this stuff is the entire right-hand side of the equation up above. So I'm going to rewrite this equation. I'm going to give myself some room down here. And I'll color code it so you can kind of see where I'm going. So we've got a1 squared plus a2 squared plus b1 squared plus b2 squared equals, and then this green stuff, so a1 squared minus 2a1 b1 plus b1 squared plus a2 squared minus 2a2 b2 plus b2 squared. So let's just kind of summarize where we're at so far, just so we make sure we're on the same page. All I did, and I'll pull up a new color here, we'll try pink, is I took two vectors, a and b, and I made them perpendicular. And then I found the hypotenuse vector, if you want to look at it like that, so we made a right triangle here. And then I know that if it's a right triangle, I can use the Pythagorean theorem. So I use the magnitude of A, the magnitude of B, I squared them, and that would equal the magnitude of the hypotenuse squared. So then we got down to this stuff down here. So what I'm going to do is, on the right side, I'm going to subtract A1 squared, and on the left side I'm going to do the same. Then I'm going to subtract B1 squared. I'll do the same thing over here. And then I'm going to subtract a2 squared minus a2 squared. And then I'm going to subtract b2 squared minus b2 squared. And so what you notice is the left-hand side ends up just being 0. And the right-hand side, pull up green here, ends up being, let's see, this is gone, this is gone, this is gone, this is gone. We've got minus 2a1 b1 minus 2a2 b2. So I'm going to shrink this a little bit so I can give myself a little room. And that purple thing is just kind of an odd circle over on the oblong shape. So anyway, this is really the punchline right here, what we came up with. So what we found out was, if we know that two perpendicular vectors exist, so if we have two vectors that are perpendicular, then this stuff, negative 2a1 b1 minus 2a2 b2, has to equal 0. Because the vectors are perpendicular, we can use the Pythagorean theorem, and when we use the Pythagorean theorem, everything cancels out except this stuff over here. So this stuff is called the dot product, kind of. I'm going to rewrite this down here. We get 0 equals negative 2a1 b1 minus 2a2 b2. Before I do that, I'm just going to divide everything by -2. And so I end up with 0 equals a1 b1 plus a2 b2. And so this stuff right here is called the dot product. And this is really where we're trying to get to at this lesson. Sometimes it's called the inner product, depending on who the manufacturer of the book is. Most linear algebra courses you'll see it, or physics courses you'll see it called the dot product. So basically what we're trying to get at is if two vectors are perpendicular, let me start fresh. I don't want to say it like that. I want to say two vectors are perpendicular. If and only if the dot product equals 0. So if you take a1 times b1, so the x coordinates on the two vectors, and add a2 times b2, so multiply the y coordinates, if you add those together and get 0, then the two vectors are perpendicular. And that is the dot product. That tells you if two vectors are perpendicular, and likewise, if you find that the dot product is 0, then you can prove that the vectors are perpendicular. So it works both ways. If you know they're perpendicular, the dot product has to be 0. If you know the dot product is 0, then the vectors have to be perpendicular. So that is it on dot product.